Yo, what's good? It's the chosen one. He's back. He's back. He did because I'm him. Alright. Uh, we're in a very good spot. If you didn't see the last video, which I don't really expect. I don't know, bro. If someone's following along with this series, that makes my day. That makes me so happy. Um, Now we have like actual sort of like we can render things, right? That's pretty cool. Okay, so what do we want to do next? That's a very interesting question. Now, maybe we make a button. Maybe we make a button. Maybe we try to like standardize buttons. All right, let me get rid of all this. I think that's probably what we do. I think we probably, I know at the end of the last video, again, like, I basically was like, oh, now it's time to like actually build some UIs. And it's like, all right, well, we could build like, I mean, the style is, like, this is reprehensible. This is awful. You know what I mean? Like, this does not look good at all. But, we could end up making something look good, I'm not really like too worried about it. I'm not too worried about the actual styling. I think actually doing fix bug where board. I don't know where board. There's something else. There's something. This part of this message got erased. I don't know how. Fix bug where border. I'll push past it. I'm gonna remove it. Actually, I'm gonna just put it up here. Oh yeah, I wanted to do like a global app style, but I mean, I don't know. I mean, why can't we just say like app, and then just make users do this? Define app, and then this is your like window. I don't think that's like the worst thing to require somebody to do. Okay, let's try to standardize button. Let's see what we can come up with. Let's call these widgets. New. I'm just gonna make button widget, because I don't know if this really needs to be a separate folder or a file, or like does this what goes into the public facing API or whatnot. You know what I mean? So alright. So Power1's namespace tie UI v3. Okay, so if we want to make a button, what are we doing? What are we doing? Are we recording? Yeah, the chosen one. Okay. All right. What are we doing if we want to make a button? Well, this, right? This is the main thing. We're creating something with text. Right, so we could say something like inline auto button, boom. Okay, and then we could say end. Or we could say like return. I'm just gonna do auto because I forget what this actually returns, and then we could include API. That's all we need to do anything. And then, what is this actually returning? Box returns an element writer. And then we want to do something like include TiOS paradigm v3 button widget. Which honestly, I don't know if we need to like really make people include that. Okay, so now let's get rid of all of these. And okay, so we create a button. Let's just see what this is, right? All right. So what do we want to control about the button? Okay, well, we want to control not everything, right? You can get rid of that. We don't like, we're only using these helpers because they're convenient. If we want full control, this is not that much code. We can write our own button, right? So one thing we probably want is const. One thing that we'll actually need to pass in can be title or text. So now we could say something like button save. And so now when we run this, we can do button save. Okay, so now here's a question. What happens if we want to change this default quad behavior? How does that work? Well, I don't know. Let's see. If we do, we can do dot quad, but I don't know if it's actually gonna work. In fact, I don't think it will. And yeah, I mean this is an annoying part, right? Why is my computer being so slow? Is it because I was running this thing? Whatever. I have a lot of shit open. It is what it is. You know what I'm saying? Whatever. Alright, so we want to be able to pretty easily say, like, you know, this probably is going to be like default to OP content width. We want to be able to easily change this. We want to be able to change any of these things. And we want to get rid of that. So I guess the first thing, let's see if we can add on mouse enter let's see if we can actually get a callback to work. Because this is going to be a pretty important shape. Okay. So that works. So we can see that shows up. But if we wanted to do something like quad width is 200, that's probably not going to work. In fact, I bet this crashes. Yep, it's going to crash. Why? All right. Well, because it expects all the quads to be grouped together. Now, this is sort of this is a real sort of architectural decision. We lose a lot because, we lose because we're building this buffer in real time. So we lose sort of like the ability to dynamically go back and change things. Now, why are we building this buffer in real time? Like the layout buffer, right? Like as we build it, we say, okay, begin element, okay, left is 100, top is 100, width is this expression, height is this expression. If we had like contents height times 2 or something like that, I don't even think we have this, set up. But we have some overloads for some things. I just haven't gone through and added them all. But like if we had like some complex expression, that gets inlined. So it's like, oh, well, you don't have to like go pointer chasing for, wherever this expression exists in memory, right? Everything is contiguous. What you need next is next in memory. I feel pretty good about that. Now, The downside to that is, okay, well, now we can't create something. Like, and this is sort of ideally how this works, right? If you want your, like, the way that I am thinking it should work is like you sort of inject stuff here in the parameters, and then you get whatever element type you get your like parent element back, and you can change it. Because this is a layout tree, right? You're primarily concerned with where things are. So you shouldn't, I don't think there should be like button and then you pass in like a quad or anything like that. I don't like that. I don't like the feel of that. I think it should be just like you're creating conceptually. What you're doing is you're creating an element. When you call a helper like button, it automatically is going to create some extra child elements that you can configure with the parameters. What man, I'm just a little sort of like I mean, what we could do, and I don't know if this is the right decision. Like, I genuinely don't know. Because we could do something like this. We take, like, quad setting, or we even take, like some struct button config, and we say, like, std string text, like, what is this? What does this actually take? See, this is kind of annoying because it's like right quad field, right expression. So what are the different types an expression can be? An expression, or a float, or a solo operation. Like, we could do something like this, right? Exper left equals op layout ledger x. And why doesn't this work? Well, because like every time we create See, the issue is like this whole like AST thing where it's like we can't like creating an expression isn't just this like we don't just store expressions in places. I mean, this might have not been very bright. This is a pretty hard problem to solve, in my opinion. I hate whenever you run like an OpenGL app and then C-line gets all slow and pissy and it's just like, what are we doing? Um, man, ha, very, very challenging. Um, how are we supposed to do this? All right, let's think about this. Um, do we just have an extra? No, because then we're gonna have to keep all these expressions in memory at the same time. Like what? I don't think that makes sense. But is there an elegant solution for writing like what? I mean, okay. So let's think about this. Let's go back to solve. So in constraint solver, we have solve, and we say, let's look at box. So we expect a quad, and then we expect a layout, right? And then we expect another element. What we really could do here and see I don't actually think this ends up using more memory, because you're either creating some dynamic tree at the beginning, and then you go from some like dynamic tree with memory all over the place, then you compile that down into like a nice like element buffer where everything's contiguous, and then you solve the layout. But the issue is like, or you could just use a little bit more memory. Expressions are not going to be a lot of memory, and just like reevaluate stuff. So like, I think what we want to do is, like, this should be like read, so element type. Let's see where we're using it. Element tree. Okay, it's declared there. Okay, that's a lot of usages. Let's say, because it's not really an element type. What we really want is like a token. We want just like a more generic token that then reads an element type. So we probably, I'll move this to the top of the file later. I don't want to go all over the place, but basically we don't want to expect certain things at certain locations. We want to read what we want to be told what we're about to get, rather than saying the first 2 bytes is this, the next 4 bytes is this, the next 4 bytes is this. We're saying use 1 byte to tell us what the next 3 bytes are, or 1 byte informs us how many bytes we're using and what they represent, and then 1 byte, little micro headers. Yeah, we use a little bit more space, but I think enum class solver, yes, solver token element type. That means we expect an element type. So we could say const, and then another token would be like quad layout. Okay. All right. Let's make a lot of progress in like 20-30 minutes. I'm not against working for longer, but it's just, I want to try to keep these videos a little bit shorter. All right. So again, this name kind of sucks. I hate two word names. Solver token, like what? Like okay, solver token, element type, quad, layout. Okay. So first, at the top of every loop, we're gonna get a const auto token equals, we're gonna read a solver token. Okay. Well, hold on. First, what I'm gonna do is, so I made this mistake last time. I'll say get status, get add, get commit, UI work, get push. All right. Okay. All right. So solver. So, if the token, switch token, case element type, we can do something like this. We could say const auto element type is that, we read it. I don't know what the use of element type is anymore necessarily, other than because we could make it so that text doesn't, you can't even call layout on text, but we get the depth. I mean, maybe element type just becomes depth, but I'm not gonna like so this is like updating the stack based on where we are in our tree. Once any changes to the stack, we have to update the context clause. We do it in stack pop back. Maybe we should have a push back. Probably, yeah. I like that. Setting the z index, I guess, because we want to do this every time for some reason. Okay. So we've read what we need to read from here. Now, if we get solver token quad, now we say eval quad. Okay. See, this is like out index. We need a better way to do this other than like it relies on an order. what out index really represents is like okay, here's what element type does. Because we can actually know what the element type is, and we know the element type is either text or box. We're not doing layout or root. We know that out index is going to increase 1 and this is for layout. So we should, because we're using it here, we should be able to do something like switch lm type case element type box out index plus equals 2 break case element type text out index. We can just do that, and then we can just do default, and then let's just throw. Just yeah. Okay. If we expect a quad, we're evaluating the quad, but we're not changing which quad we're evaluating. If we get, and then we don't actually need, we can do our like spaced out method, you know what I mean? And then we could do case, I wonder if, that looks not horrible. Okay, so then we evaluate a quad. Then we say solver token layout eval layout break. I don't know what we use text index for, but do something like that. I love my spaced out switch statements. They are so easy to read. All right. Okay. Haha. So now we just need to add these solver tokens everywhere. Okay, easy enough, right? So element buffer writer, thankfully we have a file for this. Right, expression. So what are our main things? Right, element. So we need to say writer.lm buffer writer.write solver let's call it solver token element type. But I don't think this thing... Oh, I guess it does. Alright. I would think this wouldn't include the solver, but I guess it does. Okay. Now we expect that, so now every time we write a quad, oh, haha. Man, API design is a crazy thing. So quad field left. Oh boy, this is hurting my head. Oh, jeez, and I'm tired. I gotta keep going. I can't leave it like this. Okay. See, there's no clear way to say which function is gonna start a quad. So, what we could do is we could either enforce, but what if you only want to specify top? You should be able to compose this, right? Like I should be able to do button and then dot and then change whatever I want. It should be the same exact API as everything else. Like I should be able to do button dot quad and then width. I don't want to have like a begin thing, but it's like we do kind of have to know when like we do kind of have to know when this starts, right? Do you guys see what the problem is? You see what the problem is because we do something like solver token element type, and then we know to expect element type box and depth. We know to expect these things. Next, what I'm trying to accomplish is have something like solver token quad. And then you expect stuff like quad field left, so on and so forth. And then quad field end. And the reason I don't want to promote quad field up to like token level is because we have something called, and maybe this is misguided. Maybe I'm wrong about this. But if we have quad field as like this feels like a clean hierarchy to me, but again, like maybe I'm tricking myself into thinking like an object oriented dev. Like what's easy for me is the best solution, and like that might not be the case, but I also don't think like creating buffers all over the place. I think I really like my design. I really want to stick to it. I want to trust what I'm doing. Okay, so we have solver token, element type box, depth, solver token quad field left. Now, the issue, right, is when we do this, this function doesn't get called till all these get called. Now, the only thing I can think of is to say like we have an element buffer writer, so we could say something like bool is writing quad equals false, and then we could say write quad field if writer dot is writing quad. If it's not, then we say something like writer dot write this actually, and this maybe this is how we want to do children, but it's a little unclear with the children. But maybe this we'll see if we can extrapolate it. So quad or no, we want to say solver token quad. Okay. And then we say writer dot is writing quad equals true. Quad field end. Where are we actually writing that? Well, we're writing that here, and then we could say ui.lm buffer writer dot is writing quad equals false. Okay. This is pretty surefire. Like, I'm pretty okay with that. And we could probably do layout the same way. Now, the issue... Oh, man, this is a lot harder than you would think. Left top width height. Okay, that's solved. Now the issue, right, is like let's say like what we could do is like let's say we have like quad and layout specified, and then we go and like specify them again somewhere else, or like we have this quad layout style children quad layout at the end. Okay, why would we resolve like how does this mess with the constraint solving thing? So like let's say we know left is 100 and top is 100, but we're waiting. And like all right, so we know left is 100, we know top is 100, but like we have one box on I'm gonna say left equals unresolved, top equals unresolved, width equals unresolved, height equals unresolved. So we're waiting till the end of this element to actually do anything about this stuff. Okay. Let's see. So now we have a child. We have some buttons. So we have box at 0. And then let's say we have box at 1. That means that left is boom, top equals boom, width equals boom, height equals boom. Then let's say we have box 2, left equals boom, top equals boom, width equals boom, height equals boom. Okay, now we have text, let's say txt at 3. This is depth, by the way. Left equals unresolved, top equals unresolved, width equals... Because if everything... Let's say width is 30, height is 10. Wrote the wrong thing. Okay. Now, when we pop, we may end up see, this is the problem, right? We might not necessarily oh man, I'm tired, I'm sorry. One, two, three, four. See, we might go back to 3. I'm just gonna use these as IDs. Because we might go back to ID 3 and because box with ID 3 happens, maybe we specify more quad or layout information. Like we should never push onto the stack until we actually encounter. Yeah, we should. Okay. Yeah. That makes sense. That I can logically work with. So whenever we're actually done with 3, whether that's directly after 4, or we also specify another quad or layout, that's when we calculate all of 3. So we say box at depth 2, left equals, let's say it's layout ledger X, boom. But let's just say, there's some margin. So we have width is 40 and height is 20. 5 is the margin. Okay, now, and this is a pop. Now we get back to ID 2. Box is L equals question mark, top equals... Oh, but we actually have to specify this. Because this can't have a parent. So... Oh, no. Shoot, okay, hold on. Because the whole point of not actually calculating where you are. The whole point of not actually calculating where you are is so that you can do it at the end. But that way it's hard to pass things down into children. So let's say this has to be, I'm going to say like this has to be a 5-5. We've explicitly said it. But because we could just as easily write, actually, let's just assume for the sake of discussion, we're always doing something like this. Okay? This should be valid syntax. It really should. There should be no order that you're required to declare this stuff in. Shit. I feel like I need water. I gotta get some water. I'm losing it, lads. I'm losing it. Oh. I'm trying to lock in, but very difficult. Alright, we're almost at an hour, so I'll give it another 10 minutes. Sorry, I gotta also try to deal with some insurance stuff, from the unemployment, Just I gotta be on call, sorta. So that means it simply may be undefined. We're not even gonna attempt to resolve it. So, and then let's say everything else uses layout X. But because we do like L is question mark or box 1, what can we extrapolate from here? We still don't know where this gets drawn. You guys assuming this is like layout ledger X or parent or something like that. Its width and its height are probably informed by the children, equals 50, 30. And then ID 1, box 0 is left equals question mark? No, left equals 100, top equals 100, width equals content width, so that could just be 50, height equals 30. Pop, and then we're done. Okay, so that's what's known on pass 1. Then on pass 2, if this is like layout ledger X or something like that, this should be resolved, so we should be able to fill that in. But if we're doing this at the end, right? If we're not attempting to fill this out until we're done with the element, then its children don't get to know where to draw. So then the number of passes it takes to resolve is a function of how deep the tree is. Yeah, I don't know. This is I don't. Maybe my design has a big flaw in it. Maybe there does need to be some sort of intermediate step where we just say, like, where maybe we do want to force it to be in a certain order. And we do have these ASTs all over the place. God. Well, what we still could do is say, okay, we could still have some sort of like long expression buffer. And then we could have indexes into that expression buffer. And most of the expressions are going to be somewhat contiguous. So we could do that, which is sort of how we were doing it before. And yeah, I think we're gonna have to do that. All right, I want to make another video on actually getting this shit done, but thank you for bearing with me if you locked in for this one. This one was a rough one. All right, peace.